Good morning. This is our third experiment. The aim of the experiment is to conduct block rotor and no load test on single phase induction motor. In this experiment, we perform no load test and block rotor test on single phase induction motor. We use no load test to calculate the core losses, friction and windage losses of the induction motor. And we also calculate the no load resistance and reactance of the induction motor. So first of all, we are going to make the connections of the experiment. We supply this is our input supply. We provide input supply to the variac, that is variable AC. It is also known as the auto transformer. This is the input supply of induction AC variac, and now we take the output from the variac. We provide input to the ammeter side. We forwarded the supply. Now we are going to connect the ammeter. As it is the property of the ammeter that it is always connected in series with the circuit. So here is the sign of ammeter. We are going to connect the ammeter according to this sign. Now we are going to put forward the supply. Now we have done this, forwarded the supply. Now it is a property of voltmeter that we connect voltmeter always in parallel. We always calculate the voltage in parallel because in parallel the voltage remains same. So upper one is phase and lower one is neutral. So now again supply is forwarded to the wattmeters. Here there are three terminals of the wattmeter. This is W1, this is W2, and the lower one is W3. Now we forward the phase and neutral. This is the running winding of induction motor. We connect running winding to the induction motor. This is the phase, now neutral. Now we connect the capacitor with the capacitor. Now starting winding. Now supply, we put it forward. This is the complete connection diagram of single phase induction motor. Here ammeter is connected in series, voltmeter is connected in parallel, and here is the wattmeter connected with its three terminals. Here is this running winding, that is the main winding of induction motor. As it is a capacitor start induction motor, so we connect a capacitor with the induction motor. We connect capacitor with the induction motor to provide the initial starting torque, because in single phase there is equal positive phase and equal negative phase, so net torque is 0. To provide the extra initial torque, we connect the capacitor in the induction motor. Initially we perform the no load test. In no load test, motor is free to rotate. There is no load on the motor. In no load test, there is very high voltage drop across the windings of the motor, but very small amount of current flows in the motor because of the core losses in the motor. Now we are going to start the motor. Initially we make it MCB on. Now we are going to supply the voltage, that is the 220 volt. As you can see that motor is running.
बंद कर
Now we have started the motor at its rated voltage, that is 220 volt. And now we will note down the reading of ammeter, voltmeter and wattmeter. From here we can calculate the no load reactance and resistance of the motor, and friction and windage losses and core losses of the motor. Now we switch off the motor. This is the no load test. Now we are going to perform the block rotor test. This is also known as the short circuit test. Or for short circuit test, we are going to put the load on the induction motor. Here we have blocked the rotor. That is it is not able to rotate. Here we have put the load on the motor on both the terminals. This is the weight we have put on it. We perform the short circuit test or block rotor test on the induction motor to calculate the copper losses and leakage reactance and resistance of the motor. For block
5 एम्पीयर
पॉज करें.
Now we switch on the motor and we provide the rated current to the motor, that is 5 ampere. Now we increase the voltage from the variac till the current reaches to 5 ampere. The current has reached to 5 ampere. Very minute amount of voltage drop is there, but high amount of power is there, and the motor is not able to rotate, and it is giving some humming sound. From this test, we calculate the copper losses and leakage reactance and resistance of the motor.
Super. Thank you.
Thank you.